Hey guys, now we have another example of differential equations which can be solved by variable separable. We all know from our previous video that we have to separate the x variables from the y variables. Now we have an example here which is dx plus y dy equals to x squared y dy, which we will be then separate in order to get to our answer. So to separate them, it will become dx equals x squared y dy minus y dy. Next is dx is equals to y times x squared minus 1 dy. We just simplified the value in order to be able to separate them. So dx over x squared minus 1 equals to y dy. Now, dx over x squared minus 1, when integrated, cannot be solved in normal means. So, we have to use the operation called the partial fraction of dx squared minus 1. So, we will use partial fraction. So the general standard form of the partial fraction will be 1 over x squared minus 1 equals to a over x minus 1 plus b over x plus 1 multiplied to x squared minus 1. So we'll be using this standard form in order to get the partial fraction of dx over x squared minus 1. So on to our solving. So 1 equals to a multiplied to x plus 1 plus b x multiplied to x minus 1, and we'll let x is equals to negative 1 and 1 is equals to a multiplied to x plus 1 plus b multiplied to x minus 1. And on the other side, we'll let x be positive 1. So 1 equals to a multiplied to x plus 1 plus b multiplied to x minus 1. So we'll just substitute the value of x. So 1 equals to a 1 negative 1 plus 1 plus b negative 1 minus 1. So a multiplied to negative 1 plus 1 will be cancelled out since negative 1 plus 1 is equals to 0. So 1 equals to b multiplied to negative 2. So b is equals to negative 1 half. So for the other side, it will be 1 minus equals to a 1 plus 1 plus b multiplied to 1 minus 1. So b will be cancelled out because 1 minus 1 is equals to 0. It's the other side. So a is equals to 2, which is translated to 1 half. Now we got the value of our b term and our a term. Now we'll just substitute each value to the standard form or the formula of the partial fraction. So 1, we just use the standard formula. So 1 over x squared minus 1 equals equals to uh, a, which will be substituted by 2 multiplied to x minus 1, so minus the integration of 1 over 2x plus 1. And now we'll get the value of uh, 1 half multiplied to 1 x minus 1 minus 1 x plus 1 dx, which equals to 1 1 half multiplied to ln x minus 1 minus ln x plus 1. So to get the result, the resulting value will become integral of 1 over x squared minus 1 equals to 1 half ln x raised to ln x minus 1 over x plus 1. Now, this is the partial fraction of dx over x squared minus 1, which we will be then inputting on our original equation. So, result will be 1 half ln x minus 1 over x plus minus 2 equals to the integration of y dy, which is y squared minus 2 plus ln the arbitrary constant c. So we will multiply this equation to 2 in order to get rid of all the halves. So the resulting value will become ln x minus 1 over x minus 2 x plus 1 equals to y squared plus ln and the arbitrary constant c. Next, it will become ln x minus 1 equals to y squared plus ln arbitrary constant c as it is plus ln x minus 1. So this is now properly separated in order to get our proper answer. So we'll oh sorry we'll multiply this to e on both sides, so cancel out some ln, so it will become e raised to ln x minus 1 equals to y squared plus ln c ln c multiplied to x plus 1 x plus 1. Now this is our desired process, so we cancel out the e and the ln, which will result to x minus 1 equals to y squared, equals to e y squared plus e ln of c multiplied to x plus 1. So next it will become x1 equals to e y squared plus ln c multiplied to x plus 1, which is just combined through the exponential process. So with this equation, we can simplify this in order to get our desired answer. So x minus 1 equals to e ln absolute value of c multiplied to x plus 1 raised to y squared. So cancel out e and ln, which will result to x minus 1 equals to c x plus 1 raised to y squared. Raised to y squared. Now that we have this value, this is our final answer. So thank you for watching, guys. See you again for our next video.